Look at digital lockers. All right, here we go. Section 5.2. We talked just briefly. I'll just review real quick what we talked about on section 5.1. We talked about a word called the circumcenter. Do you remember that word? Okay, the circumcenter. How did we find the circumcenter? It was a point somewhere in the triangle. How did we find that circumcenter? What did we draw in the triangle?
Make the equidistant
Perpendicular bisectors. Okay, let me just go through this quick. Okay, so in order to find the circumcenter, we find the perpendicular bisector. So what do? You find the midpoint, and you go perpendicular to that midpoint. Everybody follow me? So we find the midpoint, we go perpendicular. Midpoint, perpendicular, midpoint, perpendicular. Guess what's true about all three of those lines? They intersect at a point. What do we call that point? Call it the circumcenter. All right, that's just, now that point right there was equidistant from the three vertices. This is all review. You can look it up on the YouTube video if you forget this stuff. All right, it should be in your notes. All right, you should be taking notes on this. So that point right there, the circumcenter, was equidistant from the three vertices. What was the next word we did? Do you remember?
incenter.
Right, it was the incenter. You can look at your notes. And how did we find the incenter? We did what to the angles? We did something to the angles. What did we do to them? Found the bisector, right? We bisected these angles. So I'm going to write it like this. It's the angle bisector. All right, so we did the angle bisector. Took this angle, split it into equal angles. Took this angle, split it into two. Took this angle, split that into two. All right, all three of those lines actually meet at one common point. That common point is called the incenter. Remember that common point? That common point is the same distance to the sides of the triangle. All right, so that point would probably be in here somewhere. If I took the distance right here, and I took the distance to here, and I took the distance to here, all three of those lengths would be the same. Again, I'm not going into a lot of detail on this. You can look at the video to see how it's drawn out and that kind of stuff. The reason I'm going through that is because we're going to do two more today. All right, we did circumcenter and incenter. Now we're going to do two more, and I just wanted to make sure that we went through that, just to remind you of what we were doing. All right, here's another word. It's called altitude. Right, it's like an airplane. Okay, so watch. Here's the ground, and watch my cool airplane. That's my airplane. Boom. See the wings? Isn't that cool? All right, that's where the pilot is. All right, that's his cockpit right there. So watch. When they say the altitude, all right. Rashid, you came over on a plane, didn't you? You came over on a plane, didn't you? What do they? Does the pilot talk to you up there? And he tells you stuff. He tells you, like, you know, where you're going to land, what time you should be there. He tells you what the temperature is going to be and all that kind of stuff. But one of the big things he tells you, especially when you're up in the sky, he tells you the altitude. You happen to remember what the altitude was when the pilot got on there? No? That's all right. I don't think they go quite 50. I think it's somewhere around 20, 30,000 feet, okay, if I remember correctly. All right, so what are they talking about? If they said we're flying at 30,000 feet, does that mean it's 30,000 feet until you get to where you're going to go? Does that, it means how high from the ground? Well, that's off the ground right there. Is it that distance? Straight up and down? What is it? Perpendicular, right. Okay, it's the perpendicular distance, okay? I understand what you mean by straight up and down, but we're in geometry, so we'll use geometry words, okay? So that's the perpendicular distance. That right there is the altitude. Everybody follow me? So if this plane keeps flying across, that perpendicular distance from the plane to the ground would be the altitude that the plane's at. All right, so perpendicular's got a lot to do with this word altitude. So what we're going to do is we're going to draw an altitude on this triangle. Where do we start, though? We start at a vertex, start at a point. All right, and that point is the vertex. And so where are we going to draw it? We're going to draw it down to here?
Perpendicular.
We're going to draw it perpendicular. Okay, so that would be perpendicular right there. That right there is an altitude of this triangle. Everybody with me on this? It's not hard, is it? All right, altitude means you start at a point, and it's perpendicular to the opposite side. So we start at a vertex, and we go perpendicular to the opposite side. We good with that? Well, we can draw how many more altitudes in this triangle? Two more, right. Abby, you getting all this down? Yeah? Sure. No? What are you drawing? You're like drawing stuff. You're not even drawing math stuff.
snowflake.
Okay, right. That's what I thought. That's what I was talking about. All right. So what do? Do we go to here? Down to here? Now we go so it's what? Perpendicular. Now we're just eyeball it. I'd say about right in down a little bit more.
No, a little bit more. A little bit more. Right there.
I'd say about right
That's
there.
not a 90 degree.
Sure it
Yeah,
is.
It's just those wires.
Okay, so we'll make that connect. All right, so we'll say that's an altitude. So where did I go from? I went from the vertex. Are you listening to me? From the vertex, perpendicular to the opposite side. Everybody got it? Let's do one more. We got one more to do. I already went from this vertex. I already went from this vertex. So now where do I go? I go from the other vertex. So let's go here, and we'll go perpendicular. Now, guess what? Since this is kind of like section 5.1, do you think it's going to go here? You think it's going to go here? Where do you think it's going to go? It's going to intersect those other two lines. That's right. If we drew it correctly, okay, if we were drawing it to scale and being very careful with this, then if these were all perpendicular, it would definitely go right through this point right there. What do we say about those three lines? They all intersect each other, but we had a special word if three lines meet at one point. No, not, what is it? Concurrent, right. We say these lines are concurrent, okay? But we have a special word for this. They're not just any old concurrent lines. They're special because it's formed from the altitude of these three, or it's formed from the altitude of these triangles, the three altitudes drawn from the triangle. Okay, so I've got this point right here. We give that a special word, and we call that the centroid. Isn't that cool? Yeah, centroid. That's what this point right here is. It's called the centroid. Everybody with me on that? All right, so that's what I call that point right there. Let's label these A, B, C. We'll call this D, E, and F. Okay? Now, there's something special about this centroid right here. Everybody following? It's concurrent, right? So all three lines intersect at that particular point right there, but I did not draw this very accurately.
I told you.
Yeah, you did. Yeah, because that one right there, right? That should have probably gone way down here.
Yeah.
Let's do that. Now looking at it, Brett Natsu, you were right. How's that? I'll give you props. I'll give you props and everything. No, that's all you get. All right. Let me do that. Let's get rid of that circle. Let's try this again. So where do you think it's going to be?
I'll put it a little lower.
A little lower? You think?
A little bit.
Yeah,
Just
I
a
mean,
little
a
bit.
Keep going.
Right there.
Tell you what. You know what I'm going to do? Let's
Take a protractor.
Nah, I think I can do this. Watch. I'm going to ungroup it. Watch. I'm going to grab this. I'm going to copy. Actually, let's do this. Home. Transform. Rotate 90 degrees. Actually, oops, sorry. Let's cancel that. Let's do this. Let's copy. Let's paste. All right. Don't start yapping. I'm just trying something here, so just pay attention. Just sit there and just watch. Hey, just sit there and watch. Stop talking. Do I got to be rude about it? All right, there we go. Now that is perpendicular because I made it 90 degrees. So there we go. So look, I was pretty close before. So I wasn't that far off, to tell you the truth. So that's definitely perpendicular right there. I'll tell you what, just for the fun of it, just so that I get this to be kind of accurate, watch, I'm going to copy and paste that. And let's rotate this 90 degrees as well. There we go. And watch this. So this goes from this point, and that's perpendicular. Hit the shift, which keeps it the same angle. So there we go. There we go. Look, that's perfect. Let's make them red, though. So that's right on right there. Oh, you know what?
What?
Oh my goodness, I can't believe I did this. I got ahead of myself. I was looking at this and I thought, no wonder. Now I know. Sorry about this. Wow. This is not called the centroid. I am so sorry about this. That was my mistake. I'll give it another word. Sorry about that.
It's called Android.
Watch this. It's called the Orthocenter. And I went out of turn because this is the last thing we did in the other class, and for some reason that was still in my head, and I completely messed this up. Sorry about that. But this is called the. Let's not have any comments, please. This is called the Orthocenter. So sorry about that. And let's make that red. There we go. All right, so that point right there, and these are all perpendicular, and I made sure that they were because I copied and pasted and I rotated at 90 degrees, right? So you saw exactly that they would be perpendicular. Well, that's an ugly looking box. That's even worse. Anyway, you get the idea. So look what they do. They all intersect right there at that point. I didn't have to eyeball anything. I made that exactly 90 degrees to this. I made this one 90 degrees to this, and this was already perfectly 90 degrees, and they intersect right there at that point. They call that the orthocenter. Now, the orthocenter, though, is the one that's kind of left out. It's really, there's nothing special about that. Do you remember the circumcenter and incenter? They had something special. They were equidistant from the vertices, and the incenter was equidistant from the sides of the triangle. There's really nothing special about the orthocenter. Okay, sorry about that. But that's it. All you got to know is if I draw the altitudes of this triangle, they meet at this point, and what is that point called? It's called the orthocenter. And there's nothing special about that orthocenter. It's not equidistant from the three vertices. It's not equidistant from the three sides. I mean, look at this. Is this side and this side and this side right here equal to each other? No. There's nothing special about it. It's just the fact that it intersects, and it's called the orthocenter. That's it. All right. Now the next one we're going to do should have been the first one that I did today. Sorry about this. I've done this once already. You figured I'd get it right. But the orthocenter, there's nothing special about it. And how'd you get the orthocenter? You found the what? The altitude. And that's all you got to know about the orthocenter. All right. Let's do another one. We'll do this on another video. And there is going to be something special about this. Okay. And that's really what I want to concentrate on today. So let's go to another video, and we'll do the next part.